Here we have our traditional location signalling case at Consall signal box on the Trinity Valley Railway, which runs our main interlocking here. We have outlying location cases with track circuit indications in, track circuit relays and also signal indications, and they feed back into here on the cables at the bottom. But just to take you through a traditional location case, so here we have our shell type relays, which are supplemented by some plug-in relays of a later type. These ones are, I can remember exactly, these are PN1 types. A lot of the West Coast re-signalling in the 1950s used a lot of these, and we're using these for part of our token machine circuits as well. And we have some various different types of shell type relays here. We also have some polarised relays, I'll get to that in a minute, and a modern 930 timer relay which we're using there. So if we have a look at our shell type relays to start with, this particular one has a Remax top, as we call it. So if you undid this screw here, this whole rack of contacts will be able to come off and lift off. That saves having to take every single wire off separately. Unlike this, which is just a standard shell type relay without a Remax top on it. If you wanted to change this relay, you would have to take every single wire off. So you can see the benefit of the Remax top. The thing to remember with these is that when you undo them, they wouldn't have been undone for years, so sometimes you have to take them in and out a few times to make sure that they go in properly. There is a kind of a pin code on this, which is what these pins are for here on the front. So when you screw the Remax top on, it will only go onto the correct base. Obviously with this you don't have any pin code. You attach the wires separately and you ensure that you get the correct type of relay when you replace that. But at least with the Remax top you don't have that problem. There is a form of a pin code on it. You can see this one here has a different pin code. Pin code is actually on the fronts as well. So BDC, BDC. Okay, the labels come off this one. This would be BDR and BDR. We have, in this case, our coils, R1 and R2, which mirror up to R1 and R2 on here as well because of the Remax top. On a traditional relay, R1, R2 there. Some of them have the coils on the back as well. You can have them around the back, so you've got to be careful of this. They are quite old, but as you can see, you can still see the terminals on there. So that's contact set number 2, 1, 2, and that's the back contact, the de-energized contact on the bottom there. You can get a good view inside on the shell type relays. That's what I do like, as opposed to some of the 930 types that you struggle to get to see in. So on this one, this is a 6-arm front and back. 1, 2, 3, 4, 5, 6 sets. Armature, front and back. So if you were to look at the relay, there's your armature, there's your front contacts and your back contacts. A little bit different on the PN1s. It will be shown on the front what they are. So this is an 8 front, 2 back. So as you can see, we've gone from this size down to this size. So it's been miniaturized. And then you can miniaturize it even further into the modern 930 series. Polar relays, these work slightly differently. These relays here, if you take the voltage off, they will de-energize. The contacts will drop. If you put the voltage on, they will energize. The contacts will pick. With the polar relay, this is driven by the polarity. So depending on which way you connect the positive and negative to the circuit, will either drive the contact across, or if you have an altered polarity, it will just simply drive the contact the other way. Now it does have a backstop on it, so with the wrong polarity it will just simply try and push that contact further into the stop. There are other versions of these which are dual contacts for changing signal indications. So the big square ones, again 250 ohms, same as this, but whereas this has got a single contact and only moves the one position, the dual arm ones actually give you the ability to swap the voltage internally for the outputs used for signal indication circuits. And you can see there's 2 versions of this. There's an older version and a newer version. Newer version in a complete plastic case. The label is actually just on top here. You can't really see it. I can get my phone in there. It's just on the top there, the label. And again, R1, R2, which are coils, normal, armature and reverse contact. This one actually has a Remax top on it again. That little screw there, if you were to undo that, and they are plastic, which isn't the greatest idea, that would come off and you can then change polar relay and put this back on. This one doesn't have a Remax top on it. Moving down, again, we have our standard polar relays. This one is our timer relay. This is a shelf type timer relay. This is a thermal element relay. So as the timer, you will have seen in one of my other videos, initiates, this bimetallic strip at the top here is heated up by that heating coil that's just hidden underneath the insulation there, and that forces that contact to start to bend upwards, breaking one of the relays in the circuit. Once it's timed out after a set period of time, which you can set on an adjusting screw just under that cover there that's secured down, it will then cool, and as it cools it will remake that contact. When it remakes the contact, it's proved that it is timed effectively and reset effectively. It's gone back to start, makes its output relay, and that's what that relay is. Very similar design case to a lot of the block relay relays that will use this type of design of case as well. Last to talk about is this rather nice little beast here. Now this is an old metal case one. This is a polar neutral relay. Now, as you can appreciate, this is a neutral relay. If you put the voltage on, it energizes, contacts make. If you take the voltage off, it de-energizes, the contacts drop. The polar relays, if you put a polarity on one way, it will drive the contact one way. If you put polarity the other way, it will drive the contact the other way. This has the benefit of both worlds. So inside, you can just make out there's some polarized contacts, so it will effectively rock sideways depending on which way the polarity is. Also, it has its neutral contacts, the same as any old shelf relay, which will energize and de-energize. And the benefit of this is it will remember where it was. So if you can appreciate inside this, when the correct voltage is applied and the correct polarity, it will not only energize but will then rotate and make its contacts. If the power fails, it will drop, but it will be in the same position where it came. It's almost, not quite the same, but almost the same principles as a latching relay, which we haven't got on our railway, but latching relays magnetically hold themselves up. You have to de-latch them magnetically to drop. And we use this for our point detection. Similarly, there's another one of these used at quite a few railways actually that I know of. I use one on Peak Rail as well for its point detection down at Riverside. We use the detection here for the motor points as well at Consall. Good solid relays, quite old now, but definitely the biggest thing in the cupboard, as you can appreciate. Contact wise, all the contents on this are slightly different. So you will have 8 reverse, 8 normal contact, 8 armature contact, which doesn't sit in position 8 at all. So these are 1, 2, 3, 4, 5, 6 in a nice line. These are totally different. So you've got to be careful reading the little labels on them if you're going to use them in your wiring schemes. And then below that we have our bus bars and we have our incoming outgoing cables.